Okay, you got the handout there, but before we get to those problems, let's talk a little bit about work problems. Work problems, this is a way we can compare different rates, right? Now, you can't compare people or situations unless you're within the same, say, time frame, okay? So, for example, if it takes you 3 hours to complete a job, and it takes me 5 hours to complete the same job, all we can really say is that you work faster than me. We're not really working at the same rate. I'm working at a slower rate, but the main thing is it's definitely not the same rate. Okay? The same idea that you've seen before, if you're measuring something in, say, feet, and then somebody else is measuring something in meters, they're not going to equate. You have to equate them to get down to the same units. That's kind of the idea. Okay? All right, so here's what I want to say for a work rate. If it takes you 3 hours to do a job, that means that you complete 1/3 of the job every hour. So we call it a uniform work rate. If you're working at the same pace, it's not a 3-hour job and you took a 30-minute lunch break in between. You're working the same amount each hour, same pace going through complete, and you complete roughly 1/3 of the job every hour. Does that make sense? So if you're going to work a job, if it takes you 6 hours to complete a job, well, you're completing roughly 1/6 of the job every hour. Does that make sense? All right. So we're comparing two. So on number one here, we got Mary can sweep the porch in 10 minutes. Maria takes 14 minutes to do the same. So let's think about this. We're in minutes instead of hours. Mary then completes 1/10 of the porch every minute. Maria completes 1/14 of the porch every minute. Does that make sense to everyone? Is that part each hour?
Do you have any tests for the testing center today?
No.
Okay.
So we want to find out how long it would take if they work together. All right, so here's how we're going to set this up. We got Mary and Maria. So we're going to go Mary rate plus Maria rate equals together rate. So we're going to talk about the rates. That's how much per hour. Okay. Mary takes 10 minutes. That means her rate is 1/10 per minute. Finishing 1/10 of that porch every minute. Maria, 14 minutes. She's finishing 1/14 of that porch every minute. And we're trying to look at what happens if they work together. So how long does it take if they work together? I have no idea at this point. If they work together, I don't know how long it's going to take, so I'm just going to call it X. Okay? So together rate, 1/X. And I'm just saying X minutes. So 1, whatever it is. So let's say it took 7 minutes if they work together. This would be 1/7. Okay? I know this much. It's going to definitely be less than 10 minutes. A lot of times we look at it and we think, well, if they work together, it's 12. Well, if Mary could do it in 10 alone, what's the point in having Maria help out? It's got to be less than 10, right? There's no point in getting help that's going to make you work slower. You wouldn't want the help. You wouldn't want to pay somebody to help you if it makes you take more time to do the job, right? It's to lessen the time. Right? So I don't know what it is together. That's why I'm calling it X. Now we're going back to what we had last unit. One of the last things that we did was we solved rational equations. Rational equations just meant an equation with fractions. And what we did was, if you remember, we multiplied by the common denominator. And that's how we cleared the fractions. We multiplied by the common denominator, and that cleared the fractions. Gave us something easier to solve. Now we have, if you remember, kind of jog your memory here. We had some uglier ones, something like this. We had uglier looking denominators, and we multiply by the common to get rid of them. We're doing the same thing here. These just look a little bit better instead of a plus or minus down there. Okay? So our common denominator. We know there's an x. What would be the common between 10 and 14? Tough one with the bigger numbers, huh? We could just go 140, couldn't we?
Yeah.
Sometimes it's tough when you get bigger numbers. You've got to think of what it is. Worst case scenario, you can go 140x. I mean, there is a smaller one. But if we use a bigger number, we're just going to have to reduce in the end. It's not a big deal. Okay? So let's see, 10 goes in here 14 times. So we'd have 14x plus 14 goes in there 10 times, 10x. X cancels, 140. And remember when we got rid of the denominators, it gave us an easier equation to solve. It didn't make everything simple, but it was definitely easier than what we started with. Now we have a pretty quick equation here. 14 and 10 is 24. 24x is 140. And then I can divide there. So we're going to have 140 divided by 24. Let's get a calculator. What's that give us? 5, 6.
It's gonna be 5.8.
5.8?
Yeah.
Okay.
3 repeating.
That's okay. So we'll go nearest 10. 5.8 minutes. Now let's just think about this. Doesn't that make sense? It's going to take roughly about just under 6 minutes if they're working together. We know it's going to be less than 10, or there's no point in Mary even having somebody else come in and help. I don't care how fast or slow Maria is versus Mary, it's still going to be quicker than what Mary does alone. That should make sense. Okay. So you get roughly close to 6 minutes, 5.8 minutes, fine. So this is the key we want to remember right here. Individual rate plus individual rate, together rate. Okay. 2. We got Kim's 10 minutes, Kristen 15 minutes. What would it be if they worked together? Okay. So we're going to have Kim plus Kristen equals together. So it takes 10 minutes. 1/10 is Kim's rate. Kristen is 15 minutes, so 1/15. Together, I don't know. 1 over x, and we're back to a similar situation. Okay there? Okay. Common denominator. Let's see, 10 and 15, they both go into 30, so I can use 30x here. I see some common denominator that's going to eliminate those fractions. 10 goes into 30 3 times, so 3x. 15 into 30 twice, 2x. X's cancel, 30. That gives me 5x is 30. And so x is 6 minutes. Are you okay there? Okay, let's skip number 3. We're going to skip number 3 and go to 4, mainly because 3 is the same thing. We're going to skip over to 4. takes Mark 10 hours to dig a 10 by 10 foot hole. Jennifer could dig the same hole in 8 hours. How long have they worked together? The main thing for you to understand is that we got to be in the same rates. We went from minutes to hours, but they're both in hours. So we're good. If one of them was in minutes and the other one was in hours, we'd have to equate them. But they're both in hours, so we're good to go. Right? So we're going to have Mark and Jennifer. So I'm going to say Mark plus, I'll just put Jen is together. So we've got Mark is 10 hours. So that would be 1/10 is his rate per hour, finishing 1/10 of the job. Jennifer's 8 hours. So that's 1/8. She's finishing 1/8 of the job every hour. I don't know together. So 1 over x. Oh, yeah, equals. You're right. I don't know why I put a plus. You're right, equals. Okay, so now we're going to take our common denominator. It's going to clear out those fractions. Let's just 40, wouldn't it? Yeah. So we can multiply everything by 40x. Even, again, if you didn't see the 40, you could definitely see 80, 10 times 8. So let's go 10 into there, 4x, 5x, and over here is 40. So see, that's 9x is 40. X would be 49ths, or it's 4.4, isn't it?
4.4.
4.4 hours. And I don't care if you gave me an answer in a fraction or a decimal form. It doesn't make a difference to me. All right, let's look at number 5. 5 is going to kind of switch it up a little bit. Working together, Arjun and Kim can harvest the field in 6 hours. Had she done it alone, Kim would have done it in 15 hours. How long would it take Arjun doing it alone? So when you're doing your setup, it's still the individuals equals together. So when I'm looking at this setup, I got Arjun plus Kim equals together. What happened here was I actually gave you the together rate. So I said together, it takes 6 hours. So that means over here, instead of 1 over x, we've got 1 over 6. We know the together rate, and that's okay. I know what it is together. Right? I know Kim takes 15 hours alone. So Kim's 1/15. What I don't know is how long it takes Arjun, so there's the 1 over x. Notice my initial setup. The individuals added together equals the together. The x is just sliding to the unknown. The first 3 that we did, the unknown was over on the together part. Now Arjun's the unknown, so we've got the x sitting there. Solving it isn't changing anything. I need to multiply by that common denominator to eliminate the fractions. I don't care where the x is at this moment. I care about the fact there's fractions I want to get rid of. Okay. Let's see, common here again would be 30. 30x, 30x, 30x. Remember, I'll know if I pick the right common if it's canceling out those denominators. That's how I'm going to know. Let's see, x goes 30. 15 goes in there twice, so plus 2x. 6 goes in there 5 times, equals 5x. And I know I've got to move the 2x over, but this still isn't too bad of a problem to solve. Right? I can slide that 2x to the other side. 30 is 3x. X would be 10. And move back here. This was hours, so we got 10 hours That's how long it takes Arjun working alone. So it does not matter to me where the x is. It's making no difference whatsoever. Let's look at 6. We have Adam and Eduardo. So there's my 2 people. So I'm going to go Adam plus Eduardo equals together. Now we'll fill in the values. We're told Adam. Adam's 8 hours. So Adam's rate, 1/8. Plus, equals down. 4.63. That's the together one. So 1/4.63. And I know it might look weird for a second that we got a decimal, but think about a couple of our answers back here we had decimals. It's okay. Find how long it would take Eduardo. That's something I don't know. So there's my x. I don't know how long it's going to take him. Now, you get decimals thrown in there. Sometimes it makes it seem like the common denominator is just going to be a real pain. It's not. Just use the 3 pieces you've got. Okay? Don't make it worse than it is. I can just use the 8, the x, and the 4.63. I don't even need to go multiply them. I know the 3 parts are there. I mean, I can multiply them if I want, but I'm going to have to go back and divide them back out anyway. So on the first one, the 8's cancel. So 4.63x. Second one, the x's cancel. So now I do have to multiply those out. So what's 8 times 4.63?
37.04.
37 point what?
04.
All right, 37.04. I mean, the worst part right now is you just got to go to a calculator. And equals 8x. And yeah, I'm going to need my calculator the rest of the way because I'm dealing with decimals, but it's not changing how I'm working the problem. I'm going to subtract that 4.63 over. So I'd have 37.04 is 3.37x. And then I can divide that over. And what do we get? 3704 divided by 3.37. $10.99. Okay. So we get 10.99. And I believe this one was hours too, wasn't it? Yeah, hours. To me, I think the worst part of these problems is when I do have decimals, because I can't do it without my calculator. I need some help there. But I want you to focus on the setup. We're not going to worry about number 7. 7's kind of the same thing. I'm always starting out. My individuals added together give me the together rate. So I don't care where the x ends up. It's either going to be one of the individuals or on the together. Okay? The solving process becomes the same.